AP Calculus students. How you doing? This is my first Zoom in my classroom, so that feels a little different. I am going over 4.5 A and B, the problems that you said you needed help with. The first one was problem number 13, and so I got that going. We are being asked to integrate the square root of, you can see this expression here. Again, U substitution. I would think that my U would be the inside function, 25 minus x squared, and my du would be a negative 2x dx, and that is perfect. Right here, I think I've got a great substitution, so I'm going to go ahead and do that. So I'm going to be integrating, here is my u, and then the square root, I'm going to use a 1/2 because I know I'm going to have to use the power rule here. And this is perfectly my du. There we go. So I'm going to add 1 to the exponent, divide by the new exponent, right? And let's see, we get 2/3 u to the 3/2 plus c, right? And let's go ahead then, since we were able to integrate, our u was actually 25 minus x squared. So I may be checking my key. Oh, it's a little bit before 2. I may be checking my key just because it's late in the day and who knows, just to make sure I did everything right. Right, it's like being in class. Right, so number 13, just giving a quick check, make sure I didn't do something silly. Nope, we're good. Okay, let's take a look at number 41. Okay, on 41, we have solve the differential equation. dy dx equals x plus 1 over x squared plus 2x minus 3. Oh, I can see why you would ask this. X squared plus 2x minus 3, right? And that is being squared. All right, let me make sure I wrote it right. X plus 1, x squared plus 2x minus 3. I did. Okay, absolutely. I can see why you would ask this question. This is something a little like they would do to you, a little different on the AP exam. Now, first of all, I'm going to multiply both sides by dx because I have to have the correct variables of integration with the correct variables. I know I am integrating because they are asking me to, on number 41, solve the differential equation, which means I have to remove the derivative. Okay, so the integration of dy does leave me with y, and of course this is my problem over here. Now I do see a quotient, I do see an inside function. Let's call u x squared plus 2x minus 3. Our du would be 2x plus 2 dx. Okay, so this is pretty good. You know, it kind of looks like the numerator, except it's x plus 1 times 2. So you know what? Let's rewrite that. Isn't 2x plus 2, 2 times x plus 1 dx? And I don't see a constant of 2 in my integration, so I'm just going to divide by 2. I think that I have a perfect substitution right here now. So they would do a little weird thing like that to you on the AP exam. Let's go ahead then. This is u squared. Took care of that, and then x plus 1 dx is a 1/2 1 du. Again, right? Anything is being multiplied by 1. I like my constant out front. I like my 1 in the numerator. I like my du off to the side. Okay, now, if it's okay with you, this is really u to the negative 2. Now I'm going to go ahead and integrate, add 1 to the exponent, divide by the new exponent. And I have, this is a negative 1/2 u to the negative 1. So I will put it in the denominator to the first power. And my u was x squared plus 2x minus 3. Let's do a quick check. They also asked us to, nope, they didn't. I thought there were some slope fields there. They're not. Going to do a quick check on 41. make sure that we, right, I don't have you with me to catch my silly mistakes, right? No, we got that right. Excellent. Okay, that was 41. Number 51, they are asking you, of course, to integrate. Oh, I can see why you would ask this. For cohort A, this is like a problem in class where you're like, oh, holy crap, I don't know what to do with that. But it turns out to be exactly what you need. So number 51, they are asking you to integrate 1 over theta squared. If the theta bothers you, call it an x, right? Cosine 1 over theta d theta, okay? Again, you could replace everything with x's if that's really bothering you. I see I have quite a glare on my board, but you're probably used to that. Okay, I do see an inside function, so I'm not gonna worry. I'm just gonna say, oh, I think this is all gonna work out, right? My u equals 1 over theta. Now, just so you know, I'm gonna write that as theta to the -1. You know, it's equal to that for my du. My du then, I would bring the -1 out front and multiply it and reduce the exponent by 1. That would be theta squared in the denominator, which is exactly, oh, d theta, right? Which is exactly what I needed here, except for the negative, right? So I'm gonna multiply both sides by a negative. So this scary part right here was actually exactly what I needed. I think I have a perfect substitution. Let's give it a try. I'm going to integrate. This is cosine of u, and my 1 over theta squared d theta is a negative du. All right, I know how to integrate cosine. That is sine, right? When I take the derivative of sine, I get cosine, right? And I have a negative out front. So I believe I have negative sine of u plus c. And now that I've integrated, my u is really 1 over theta. And we are done. And we're going to check, right? Let's see, number 51. How did we do? Wow, beautiful. Excellent. Number 53. Okay, on number 53, we have sine of 2x, cosine of 2x, and dx. I get what the issue is here. The issue is u just 2 of x because it's an inside function. Is u sine of 2x? Is u cosine of 2x? What's going on here? So it turns out there's actually a few different ways, a few answers, couple answers you could have here that would produce, when you input x's, equivalent output values. And I think they even have 2 listed in your book. Okay, so what I'm going to do here is I believe I see this product here. I could just make u 2x, but then du would be 2, and I think I have a lot more than that going on. So I think I'm going to make u sine of x, sine of 2x, sorry about that. And my du then would be the derivative of sine of anything is cosine of anything times the derivative of the inside function, which is 2, by the chain rule dx. All right, I think I see a u here, I see a du here, except I don't see a constant of 2 multiplying the trig functions. I see them on the angles. I think I have a perfect u substitution here. Let's take a look. U, and then cosine of 2x dx, I will replace with 1/2 du. Beautiful. Okay, I know how to integrate this. Add 1 to the exponent, divide by the new exponent. 1/4, right? 1/2, 1/2, u squared plus c. And my u is, what was it? Sine of 2x. Now, if I'm right, this is absolutely perfectly correct here. If I'm right, though, I think, first of all, perfectly correct. If I had made u a cosine of 2x, I would have had kind of an equivalent expression, but with cosine in there. I think they may have also done something here to make a double angle, but that is not really something they would do to you on the AP exam. So based on our time, we're just going to make sure that, yeah, they have 3 different answers, that one of the answers that we have is correct, and it's the first answer that they give. Later on, they give one with cosine, of course, and like we said, and then another one, they do a double angle. But we have one of the answers, so we're good. Okay. All right, let's see, just making sure we're still recording, right? If that goes off, then I have to redo it, right? That was 53. Number 55. Tangent to the 4th x times secant squared x dx. Okay, I see what the issue, same issue as before. Is u secant squared? Well, when I take the derivative of that, I would get 2 times secant. Then by the chain rule, the derivative of secant, which is secant times tangent. Oh, that sounds like a mess. Is my u just secant? Well, that would be a secant tangent. I've got more powers than that. But again, it's okay to try and have it not be right. How about u being tangent? My u is tangent, du is secant squared. Oh, okay. And I know how to do u to the 4th, right? So I think I'm okay here. So again, I just want to make a list of possible combinations. You could have checked u being secant squared, and then your du, you would have found it just wasn't matching up. You could have made u secant. Again, your du, you said, no, I don't have the right powers there. You could have made u tangent to the 4th, and then you would have said, oh, I need a tangent cube somewhere when you take the derivative. It's okay to try a few things, but I'm going to try an inside function of tangent, because secant as an inside function didn't seem to be working, plus the derivative of tangent is secant squared dx. So I like that. I see that sitting right here. I think I have a perfect substitution with u being tangent. That would be u to the 4th du, right, is the secant squared dx. Oh, that's nice. Add 1 to the exponent, divide by the new exponent. I get 1/5 u to the 5th, I can say that, plus c. And then my u was tangent. And again, you could either put, in parentheses to the 5th power, or you could put the 5 right on the end there. Okay, I'm not even going to check that one. I know that's right. Okay, getting cocky now, aren't I? Yeah. Number 67. Okay, on 67, let's see. Oh yeah, find the indefinite integral by the method shown in example 5. What they're calling this, when they say example 5, is double u substitution. Okay, here's my problem. If I try to integrate this, one of these will be on the AP exam. So if you could not do this, and probably some of you couldn't, please retry it, or email me, ask me questions like, I still don't have it. And I'm going to do what I always do, inside function, x plus 6. du, my du is just 1 dx. Oh boy, well, I see a perfect substitution. Does it do everything? Let's try it, right? So here is u. I'm going to write this as u to the 1/2, if you don't mind. Okay, I got this u to the 1/2. My dx is a du. I got that. I have this x hanging out here, and I have to make it a u. So what do? Look at your first step right here. If u is equal to x plus 6, isn't x equal to u minus 6? If I subtract a 6 from both sides, can't I just rewrite this nice little equation so it says x equals u minus 6, right? Now, can't I replace that x with u minus 6? Let me give myself some room. All right, let's look at that again. u to the 1/2. My dx is du, and this x I replaced with u minus 6. So that's why, like, you have a double substitution. You use your u expression in two ways. Okay. We need to we need to multiply. Let's multiply, and we have u. This is 2/2 u to the 3/2 minus 6 u to the 1/2 is now what I'm going to integrate. All right, let's add 1 to the exponent, divide by the new exponent, add 1 to the exponent, divide by the new exponent. All right, how's that look so far? Okay, 2/5 u to the 5/2 minus, okay, so this is 6 times 2/3. I'm okay, isn't that a 4? It is. 2/3 of 4, right? When I multiply by the reciprocal, 2/3 times 6, u to the 3/2 plus c. Okay, my u is x plus 6. There we go. I'm going to do a quick check on that, right? There's a lot going on that one. On number 67, let's see how we did. You know, they did some factoring of theirs. They pulled out an x plus 6 to the 3/2 from here and then from here. But I'm going to be honest with you, they're technically not right to do that, right? We have 1, 2, 3 terms. I think I'm going to sneeze. 1, 2, 3 terms. You can't pull an x plus 6 base from the C. Excuse me. Excuse me. So when you look in the book, they actually pulled out an x plus 6 base from both of these. That's not really a greatest common factor with this plus c, okay? We're right, okay? That happens sometimes. Hey, that's why I'm here, right? Otherwise, you would just need a book. Okay. All right, number 91, let's take a look. What was in the 90s? I don't remember. Let's see. Number 91. Oh yeah, find the area of the region and use a graphing utility to verify your result. Yeah, you know what's going on here on 91. We don't even need the picture, like you can look at it. This is another shot at the double U substitution that we just did in 67, right? Now, so here's what they have. How do I know on the AP exam that it's going to be that W substitution where I write my U and then put it in terms of X? When you see an inside function and the power is equal to the product, you know you're going to have to switch that U equation around. Okay, I'm going to make my U X plus 1. I am going to make my DU would be DX, of course. And then now I can see, okay, this would be u to the 1/3 du. What am I going to do with this x? Right here, let's rewrite this. That would be, x would be, I'll subtract a 1 from both sides. There we go. Now, this is a lower x and an upper x. Please don't write those, right? We're going to stick with our u's. Look at how much simpler this is going to be. Well, kind of, right? Okay. U to the 1/3 du, and this x I'm going to replace with a u minus 1. Okay, I believe I know how to integrate this after I distribute, right? And so right now, so I don't forget, I'm going to change my x's to u's also. That was a 0 and a 7. There we go. When I put a 0 in here for x, it outputs u, so that would be a 1. And when I put in a 7, I get an 8. So that's 1 and 8. Again, could you integrate, put the x's back in, and then use your original x's? Yes, I don't do that. Okay, let's go ahead. Let's not integrate. Let's first just distribute. Okay, that's u to the 3/3, so that's u to the 4/3 minus u to the 1/3. Okay, I'm kind of running out of room. Do you mind? All right, take a good look at this. I'm going to erase right there. Okay. All right, because I still have to integrate. So let's integrate. We'll come on up over here. I'm going to add 1 to the exponent and divide by the new exponent. Add 1 to the exponent and divide by the new exponent. Ooh, not liking these numbers. Okay, that is 3/7. Yuck. 3/7. U to the 7/3. Yuck. Minus 3/4. U to the 4/3. And we are going to evaluate that from 8 to 1. All right, let's do our f of b. There we go. F of b. Whew. When I put in an 8 here, the cube root of 8 is 2. 2 to the 7th? I don't know. I'm going to do 2 to the 7th, okay, times 3/7. Hold on. 2 to the 7th times 3/7. This is a crazy one. 2 to the 7th times 3/7. I feel like I'm cheating. There we go. I'm going to do math and fraction. 384 over 7. Who has time for that? Right? 384 over 7 minus, let's see if this looks better, right? And so this is the cube root of 8, which is 2. 2 to the 4th is 16. 16 divided by 4 is 4. I think I get a minus 12 there. Let's see, right? Minus my f of a. Oh, that's better. 3/7 minus 3/4. Okay. Now, what I would do is change the sign, subtract both of those. I would release the parentheses. And I would hope that 384 over 7 minus 3/7 comes out pretty. That would be nice, wouldn't it? So this would be 381 over 7. If it doesn't, it's okay. Nope, it doesn't come out nice. So that's math, right? So it's still 381 over 7. And then here, oh gosh, I have this negative 12 and the 3/4. Let me try this. This 12, I'm going to make 48/4. It's a minus 48/4 plus 3/4. So that is a minus 45/4. And look at these denominators are not pretty. So if it's okay with you, I'm just going to throw this in the calculator. And just putting it in. I get 1,209.28. Geez, I almost wish I hadn't given this problem. They wouldn't give you one that where you have to spend this much time on it. I'm going to turn that math and decimal just to see 43.179. Boy, if I got this one wrong, I'm going to shoot a video and redo it because I'm not going to scrap this whole video for that, right? Number 91. You know, so I'm almost like sorry that I had you do this one because it just feels, you know what, we're right. But at this point, it would definitely be on a calculator portion of an AP exam. I'm not so sure they would make you take time. Is it healthy for your brain? Sure. Not a huge fan of 91. Anyway, sorry about that. 91. Let's go on to 99. Geez, it's going to take me a while just to erase, right? All right. Okay, on 99. Oh, this says use the graphing utility to evaluate the integral. They mean it too. I just do this every so often. From 3 to 7 of x, the square root of x minus 3 dx. It really does say to use the graphing calculator. And so we are going to do that because you should take advantage of it when they say to do that. You know, like that's hard enough, right? This is a double U substitution. And, you know, we saw how complicated the last one was. I throw in a graphing calculator one so you just to remember how. So math. And going down to FNINT, function integral. There we go, right? So pretty. 3, 7, and then that is x. I just have to make sure to type it in right. I think that I don't need parentheses or anything. X times the square root of x minus 3, my dx. We're going to let the calculator handle that. I get, look at how long it even takes. It took a long time. That's how hard it is. 28.8 with some after that. Anyway, let's see if it'll turn it into a fraction just in case your book. No. So about 28.800 there. So that's nice that it was graphing calculator. Gave you some practice. 107, last one. Let's see, on 107, they want you to use, I'm going to write it in black, 107. In bold, they give you this information that from 0 to 4 of x squared dx equals 64/3. By the way, if you figured that out yourself, it's true, right? They're not just saying, hey, let's pretend like this is true. You would be able to integrate that, right? You know how. What do they want from you? They want to know, they want you to find each of these expressions without using the fundamental theorem of calculus. So -4 to 0 of x squared dx. I'm just going to go ahead and write them, and then we'll go ahead and do them. And then on b, 0 to 4 of -x squared. So basically, they're asking you to use properties here, right? On c, oh, sorry, this was a c. Here we go, b. Here we go, better. -4 to 4 of x squared dx. And then d, they would like -4 to 0 of 3x squared dx. Okay, so they basically want you to use this information, and they actually want you to kind of use your knowledge of the function x squared on its domain, right? Looks like that. So it is even, it is symmetric over the y equals, over the y-axis. Let's take a look. So from 0 to 4, let's say this is a 4 right here. So I'll make that a -4. They're saying this area is 64/3. So when you take a look, what would the area be from -4 to 0? The same. I can see it in the picture, 64/3. Right? So on B then, what would the area be from -4 to 4? It's 2 of those, right? So it's double. So that's 128/3. What would the area be from 0 to 4 of -x squared? Well, you could draw yourself a picture and make it go downward, but that's a -1 constant. Isn't this expression the same? So isn't it just this right here is 64/3? So isn't it -64/3 then, right? And then here, this 3, I can put here. And did I already do this integral from -4 to 0? I did. 64/3 times 3 times this 3, and the 3's cancel, and you get 64. There we go. So that was just using properties to go, okay, how does that area, how does that integral change? Have a wonderful day. Sorry it was so much. Doing our best at the end. You're almost there to half a calculus class.